Hello and welcome again. Today's video is about real-time pipeline simulator game that I have built from scratch. But to understand why I made this, we have to talk about why I choose IT alongside my chemical engineering degree. Because the moment I did, everyone said the same thing, bro. If you love programming, why chemical engineering? Go to computer science. And honestly, for a long time, I was confused too. But during my first internship, it clicked. I saw operators on site writing numbers on clipboards, adjusting valves, and dosing chemical based on guessworks. And I realized this whole plant is just inputs and outputs. The exact math from our dry university lectures. So why are we still guessing? In university, we study things like viscosity, wax decomposition, and hydraulics from textbooks, but we never actually see what happens when a parameter changes. Human learn by doing, not by reading, so I built a web app to link both. It is a real-time simulator. You place pump based on API gravity, connect pipelines, dose chemicals to prevent waxing in winter, and train SCADA AI digital twin to automate the entire field. And here is how it works.
Alright, this is the game. It is inspired from Pokemon. It's an RPG game, role-play based game. So this is the well area. This is our HP. This is faculty integrity, and this shows us the season. Right now it's spring. We have active mission well casing by a well casing from laptop shop and select it in your hotbar and place it on the well head marker at 1214. This is the well head marker at 1214. This is our hotbar, and this is our side trailer. We have technical service inbox, HQ operation urgent initialization well head production. Welcome to the field engineer. We got a bare side. So we have a well with API gravity of 19.2, two vertical TVD or two vertical depth of 7,918 foot, wax apparent temperature 21, and reservoir pressure 1,938. So this is our SCADA. This is the trend line for flow rate, pressure, and temperature. It changes with fluid temperature because when the fluid temperature changes or fluid property changes, this is our technical service assistance. It helps us. For example, if you do not understand anything, this agent will help you. It's connected with Gemini API, so it's giving responses from Google. This is the wellhead and lift efficiency. These are the coordinates, two vertical depth, no pump is installed, reservoir, and pressure. So first of all, we need to buy well casing, and then we will place the well casing here. You can place any using key or space. All right. Install pump by a pump PVC, PCP, or centrifugal or ESP from the shop and place it directly on the well casing. We will see our budget. We will work based on our budget. So right now I have this is my budget right now. So first of all, I will go for centrifugal pump, which is dynamic pump, high efficient for light fluid, but subject to cavitation. We will buy this. The weather season has changed. It's winter now. We have a centrifugal pump installed. Buy a gathering station and paint it, then buy pipe segments and lay them to connect to pump in, output to the station inlet. Health is decreasing as we cannot see any toxic gas or thing right now, so we need to buy equipment. We have pump. We have also a random group calibration. All we need now is to buy pipe segments. So I'll buy. Okay. And just for video purpose, I also need to buy booster station, and I also need to buy. Now for it, I have for this tool to buy a chemical spread. I'll place the booster station here. And I'll place the pipes. We need the booster station in order to increase the pressure because the gas station is too hot and we cannot reach it. Now I will need to start the pump, and I will also need to start the booster. $1,000. So we will buy a chemical. All right, expand and provide oil is going to keep your HP high resolve headers and accumulate when $100,000 in total revenue to train the AI. All right, now we need to just select $100,000.
All right, now it's time to change the pump. So we will be buying a PCP pump, which is a progressive cavity pump. We will press E button to change the pump. First of all, we need to stop the pump and then select the progressive pump from our hotbar. All right, our pump is changed. So our Renault number has changed from 22 to 194. It's still laminar flow. Our lift efficiency has changed from 10% to 50%. All right, it's time to change the pump again. Now we will be using a SP submersible pump. So let's see the computer again. Let's get a HMI. Our lift efficiency is still 60%. While the flow rate changed, our Renault number is now 233. It's still laminar. All right, so our AI is all has reached 100%, and now it's time to train our digital twin AI. Our stability convergence is now increasing. So it means that the process is optimizing. It has already reached 60%. Our flow rate has reduced to 90.2 RPM and 90 RPM now for well and a booster station. And chemical injection is 60 ml per minute. And as we need to buy the heat tracer. All right, now we can see heat tracing too. Now as it's spring, so both chemical skid and heat tracer are turned off. All right, so that's it for today. If you want to play the game, I will drop it on my server. Thank you for watching.